Okay, so we're going to do a quick run through graphing. So first, it's your simple y equals x. Super simple. It's a line, and everywhere that there's a value for x, like 1, the value for y is equal, it's 1. And x is 2, y is 2. It's super easy. So it's nice to see that and get used to seeing that and have fun with that. And even if you add 4 or 5 to x, you're going to still have a line that's just going to cross through 5 on the y-axis. So it keeps that really simple. And if you multiply by x, even if it's pi, it's pretty much just going to change the slope of the line, but it's still going to look like the same line. Yeah, it's pretty straightforward when it's a line. It's nice, and you kind of enjoy going through all the possibilities with lines, simple lines, and you love it until you see x squared. So then what happens? Yeah, it curves. And but what's nice is it usually pretty much looks like this curve. And again, if you add numbers to that x squared, then we're not going to use it. We're not going to call any names today. Your hill is just going to go up and start at 4 or 5, or it'll slope down from -4 or 5. So that's it. I'm not calling any names. I'm just going to describe what it looks like. It just looks like a hill. Okay, so moving on. Okay, so, and it's kind of cool to see if you do x cubed, notice how it changes. And thankfully it's nice and consistent. Pretty much x to the 4th power is going to be similar to x squared. X to the 5th power is going to be similar to x cubed. So to the power of an even number will look alike, to the power of an odd number will look alike. It's kind of nice. I love math. I love math for this reason. It's wonderful. So what if the power is negative, and then the graph looks like hands together? You can remember that when you have x to a negative power, the slopes will come together, similar to this. Finally, x to a negative odd number power, like x to the -3 power, the graph will look like this. Similar if it's to -5 is the exponent for x. So you can make up what that looks like to you, but it will pretty much follow that pattern. Now, what if x is the exponent? So 2 to the power of x. Pretty cool. And then you can play with again, what if it's -2 to the power of x? What if it's 2 to the power of -x? What does it look like? Wow. What if it's 2 to the x plus 4 or 5 minus 4 or 5? Just observing those patterns and getting used to matching equations with the graphs. How about square roots? What do the square roots look like? I'm not even going to talk about these. Let's just look, observe, appreciate. Oh. All right. Moving along. Next, on that note, we're going to move to functions. So we've got cosine, sine, tangent, and flipping them. And so it's really cool to see how those all come out. You basically have waves. Waves! Ah. And yeah, your cosine, your sine look alike, but similar, but not exactly alike. So it's nice to kind of compare what's happening with sine and cosine. And tangent, it's always going to go off on a tangent. Even when it flips, it still does. Okay, so finally, absolute x. Forms of v. V for victory. Yay, we got through all of that. But wait, there's more. Let's try a real problem. Okay, so looking at what I've entered into the graph here is the equation and seeing what it looks like. So we just break that down and just take that complicated half. Actually, no. Back up. We'll take the simple half. Just 4, plain old 4. And look at what this graphing calculator does when I put y equals 4. And they add like all this other gibberish. They're like, do you really want me to only write a line through number 4? Really? That's all you want? You don't want anything else? No, I don't want anything else. I just want y equals 4. Okay. So it's a line through number 4. So, okay, that's the easy half. Now the complicated half is -2 times 0.5 to the x power. So you can play around with, what if that was just 2 times 0.5 to the x power? What would that look like? And again, you compare it to what it is. And when you add 4, there you have your graph that matches this equation. Okay, I hope that helps.